And good evening, everybody, and welcome to the Sigma meeting of August 2020. For those of you who don't know me, my name is Pete Sherman. I'm the chairman of Sigma, and I'll be running the first half of this tonight. There'll be a bit of a change for the second half. But before we start, what I want to do is just run through some of the Zoom controls for you. Many of you know are probably quite used to Zoom. I think we seem to be living most of our life on Zoom at the moment. But just for those of you who are new and don't know the controls, I'm just going to show you what you can do, how you can ask questions, and how you can chat to others in the room. Right, I'm just going to put my little pointer on, it will work. Okay, the first thing you've got down here is your audio settings. Now, what you can do in there is you can test your microphone and your speakers. You shouldn't need to test your microphones. No one's coming up as a panelist. But if you're having any problems with your speakers, you can actually click this little up arrow. This pop-up menu will come along, and you can say test your speakers in there, or you can choose which speakers you want to use. So if you're watching it on a TV, maybe on a big screen, and you want to send the sound to the TV, you can choose that in there. Seeing me big on a TV can't be good, I'm sure. But there we go. Okay, the next thing we have is your little chat button. Some of you found it already, but if you click the chat, you'll get this side panel come up here. Now, the default is to all panelists. So if you type anything in here at all, and it's set to all panelists, the only people that's going to see it are myself, Richard, Graham, Tim, and Stuart. But if you actually click the little down arrow this time and change the tick down to all panelists and attendees, you can then say hi to everybody in the room, and you'll get replies, and you'll be able to see everyone that's in there. Okay, and have a chat during the break as well if you want to. Okay, the next thing is the questions. We'll ask you to put any questions you have into the Q&A, which is this button at the bottom here, Q&A, quite simple. Don't put any questions into the chat because it won't get monitored, and your questions will get lost. There's no doubt about it. We have tried this in the past and it won't happen. So put all your questions in the Q&A. Richard will keep an eye on that, and he'll then pass the questions over to Graham at the end of his talk. Okay. So all you got to do is to actually type into there and then just press the send button. Okay. You can do that anytime throughout the talk. You haven't got to wait to the end. So any questions that pop in your head during the talk, put them into there, and then Richard will ask them at the end. Okay, the next thing you have is a little raise hand button. So if you've got any problems at all, if you click that, it will turn green. Then one of the panelists will notice you got your hand up. We'll ask you in chat if there's any problems, or if there's anything you're actually wanting to say. And then we can discuss it in the chat there without interrupting the talk. All right. Now, the next thing you got, depending whether you're using a computer or whether you're using a laptop, you can change your screen size by this option up here, which is the view options. Okay. If you click onto it, you get this drop-down menu. The default is fit to window, but you can change it around a bit if you want to. If it's not fitting quite right, you can then go into there and choose what suits you the best. Okay, if it does go terribly wrong and you can't see anything, just click fit to window again and it'll go back to the default. And finally, at the end of the meeting, oops, I've lost that one. You will see that screen come up. You shouldn't have seen that just yet, but there we go. That's hopefully the only technical hitch tonight. You have the leave meeting button there. Okay, so at the end of the meeting, click that and that'll take you out of the stream. Okay. So I should be able to come out of this now, he says, hopefully. I'm going to stop the share. Okay. So as I say, welcome to our 5th online Zoom meeting. And I still feel this isn't going to be our last one. Obviously, with the outbreak in Aberdeen of late, things are not going to get back to normal anytime soon. I can see it. But before we start, I would like to, welcome new members first off. Also the visiting members. We got people in from Haas, Aberdeen, Caithness. I think we got someone from North Romilsea. So northeast of Scotland is well covered, all the way down to Dundee with Graham himself. But as a special welcome, I want to say welcome all the new members that have joined since lockdown. Joined this year. We've had 4 or 5 joins since we went into lockdown, which I think is nothing more than truly amazing, really. So I want to thank them for trusting us to be able to deliver them something. When we're not having physical meetings. So I want to thank them. Welcome them in person, and hopefully one day we will meet properly in person. So that's Bill Graham, Sam Hill, John Kinnear, Esther Law, Yvonne Newman, Glennis Oakley, David Robertson, not Robinson, that I put in the newsletter. I do apologise about that. John Strayton, Penny Strayton, Tam Thompson, and Mandy Walker. So welcome if you're here, and if not, hopefully you'll pick it up on the YouTube replay. As I say, I hope you enjoyed last month's meeting with David Warrington. If you did happen to miss it, or if you want to catch it again, it is on the YouTube channel. It will be on the YouTube channel in the next few days, so keep an eye out for that and just click on the channel. There was just one little thing I was going to say. If anyone's using a tablet to watch this at all, I would plug it in, or a phone, because it is quite a battery draining program. It is Zoom. I found that out the other week. The phone just went flat halfway through it. So I'm just going to give you a quick meeting brief. What's going to happen? We're going to have a talk by Graham Young, followed by Q&A, which will be delivered by Richard. Then we're going to have a quick 10-minute break. That just gives us time to get set up for the second half, and also for everyone else to have a little comfort break. And you can also, at that point, have a chat in the chat room with everyone else in the room. After the break, we will have Space News with Stuart. Nick should have been doing the Moray Sky at night, but he's decided to go and hold up traffic with his caravan on the A96 and other roads around here. So he won't be here tonight. And then I'll be finishing off with a little bit of club news. Okay. So our speaker tonight, Graham Young. Now I tried to do my usual Google search on Graham, but there's not a lot about Graham up on the internet. As I say, normally do this and it goes terribly wrong, which I think it would have done, because the first hit I had was some bloke from Fife who had been put in jail for 14 years. So I was hoping that wasn't Graham, so he wouldn't have been here tonight. But tonight's speaker, it gives me great pleasure to welcome all the way from Dundee, Graham Young. I must thank him for taking the time out for joining us. Graham has been a member of the Dundee Astronomical Society since the mid-70s. He was secretary for 24 years. So Richard, you've got a little bit of catching up to do just yet. He's now the actual society's librarian. He has a broad interest throughout astronomy and in related science subjects. And professionally, he's a maths lecturer at Dundee University. Graham was last with Sigma in May 2010, which is far too long, far too long. Okay, we mustn't leave it as long next time. So let's not leave that gap any longer at all. Please, everyone, welcome Graham Young.
Hey. Right, folks, I hope everybody can hear me.
Yep, we can hear you.
Great stuff. I hope everybody that's in tonight listening, I hope you're all keeping very well and looking after yourselves, and you know we'll get through this. I think the first thing I must say is I must thank Sigma for inviting me in the first place. The original invite was more than a year ago, about a year and a half ago. And my vision was of the long journey up and going by coach or by train or whatever, and then presenting this show in front of you all. But hopefully in the next couple of years, I might get a chance to do something else in the same old-fashioned manner. So thanks for inviting me. Now, I'm now into my 7th decade, and I've had a passion for astronomy since I was a wee boy. In fact, I can't even remember when my passion for astronomy started. When I was very small, I was said to be always looking at the moon and looking at the night sky and looking at stars and questioning things. So what I want to do really is just share with you my passion for astronomy, and I've got a very broad interest in astronomy. But tonight I think I'll talk about the solar system, which is a very interesting thing. It's a very large part of astronomy as well, of course. So I've called the title New Dogs on the Block, which is actually a combination of two things. It was originally something to do with an overall how our view of the solar system has changed in the last 60 to 70 years. But also it's about these new objects that we're discovering in the outer parts of the solar system, which I call the new dogs. Now, I was brought up through the 1960s, and this was what influenced me as a child. Arthur Mee's encyclopedias. There was a section called The Earth and Its Neighbours. These encyclopedias were originally produced in the late 19th century. This particular page here was the beginning of the section on the Earth and its neighbours, and this particular one came from the turn of the century edition. And you can see by the two children there. Now, the encyclopedias that we had when I was a child were actually produced in the 1950s. The picture here was very much the same, except there's just two slight differences. The children were wearing more 1930s style attire, and there was an addition on this picture. So what have we got so far? Well, we've got the sun, of course, which is obvious. We've got these comets, and then there are the worlds, the planets. And this is what really, really filtered into my imagination, really fertilized my imagination as a child of 4 and 5. It was before I went to school. I was looking and questioning what these things were. I recognized that this was the Earth. I was told that these were the continents and the countries of the Earth, and there was Britain and Scotland and Ireland and Scandinavia and all the other places. And that this was the planet Mercury, which is the closest planet to the sun. And then we have the mysterious, cloudy planet Venus. That this object here was our moon, which I was already familiar with, because you can see the moon in the night sky, you see its phases. And then these other planets further out that were much further away from the sun. We had Mars, which in those days was believed to be covered in canals or canal-like features. And then the giant planets much further out, Jupiter and Saturn. Now I'm going to stop there, because when I was looking at these encyclopedias before I went to school, that was what I knew about the planets. I knew about Mercury and Venus, I knew about the moon, I knew about the Earth, I knew that the Earth was a planet that was suspended in space. I knew about Mars, Jupiter, and Saturn, and that Saturn was the planet with the rings, and it was fantastic. And I began to learn about these things. Of course, there was 2 other planets further out. And in my time, of course, in the 60s, we knew of a 3rd planet, Pluto. These 2 planets I began to learn were Uranus and Neptune. And this page here, as I said, was taken at the turn of the century. But the updated page that I saw as a child from the 1950s version had Pluto at the top as a little round ball. So I became familiar with these planets, the 9 planets, as we knew. Now, another major influence as a child was music, because we're in my family, we all listened to music. I had an older sister and an older brother who introduced me to the Shadows and the Beatles and all the pop tunes of the time in the early 60s. But my father, he was into classical music, and in 1966, he got this record from my mother for Christmas called The Planets by Holst. And it was amazing. I was listening to these pieces of music, and they all actually represented the planets. It started with Mars, the bringer of war. And then we had Venus, the bringer of peace, which was in stark contrast. And then we had flighty Mercury, the winged messenger. And then the king of the planets, Jupiter, the bringer of jollity. And then we had to turn the record over. For those of you who are too young to know about vinyl, the record was turned over, and it started with another planet, which was a completely different tune to the one we just left, Jupiter, a complete contrast, and that was Saturn, the bringer of old age. And then there was these other 2 planets. Now, as I said, I didn't really know about these other 2 planets until actually I was told about them from this record, and that was Uranus and Neptune. And that's where it ended. So we had Uranus the magician, and Neptune, the mystic. So I asked my father, I said, well, what about Pluto? Why is Pluto not there? And he just said, when Gustav Holst wrote this music, Pluto hadn't been discovered yet. And that was true, because he wrote this during the Great War, between 1914 and 1918. Pluto was actually discovered in 1930. Gustav Holst actually died in 1934, so he actually knew about Pluto. And he was indeed thinking of adding an extra movement, but he never did. It actually happened many, many years later in the year 2000, when another composer called Colin Matthews added a piece called Pluto the Renewer. Now, if anybody's got a good grounding in astronomy and the mystics and mythology, and indeed in astrology as well, and music, and you'll have heard that additional piece by Colin Matthews, Pluto the Renewer, you might agree with me that it was actually quite a nice addition to Holst's Planet Suite. But anyway, that's one of the great influences in the 1960s. But what else was happening? Well, I'll come on to that in a second. This is how the solar system fared up in the 1960s and into the 70s. Nothing much was to change for quite a while yet. It was a very simplistic picture. We had one star, the sun, and we had 9 planets. We had the 4 inner planets, which the Earth was a member of, and we had the 5 outer planets. And 4 of these outer planets were giants, and the outer one, Pluto, was a small rocky planet like the Earth and like the inner terrestrial planets. There was also a lot of debris in between Mars and Jupiter, because if you look at a map of the solar system, you know, a map of the orbits, you'll see there's a kind of gap, and inside that gap there's lots of debris, and that was known as the asteroid belt. Other members of the solar system include the comets over here, because apparently comets are to be found in amongst the planets, because they travel in eccentric orbits and come into the inner solar system from the depths of the far outer solar system. There are comets in between the outer planets, and there are comets that even come right into the inside the orbit of Mercury, and they're known as sun grazers. So comets are found everywhere, and apparently they're just little icy bodies that come from way beyond, and when they come into the inner solar system, they get heated up and they begin to show a tail, blown back by the solar wind. So this is a very, very simplistic picture that I grew up with through the 60s. And by the late 60s, my passion for astronomy was such that I was hoping that one day they'll discover another planet, the 10th planet. When will the 10th planet be discovered? For those of you that are probably in their 70s or maybe in their 60s, you may remember in 1967, there was a series of Doctor Who episodes, and it was called The 10th Planet. And that really, really fired my imagination on this concept of the possibility that there must be another planet beyond Pluto. And of course, it was frustrating that it was never actually going to be discovered. Then, in 1977, things started getting a little bit interesting. There were discoveries made by ground-based telescopes in 1977 that began to change our view of the solar system. But meanwhile, what else was happening? Well, we had the space flights. Since even before I was born, rockets were being sent into space, and then Sputnik was launched, and then we began to send cameras into space, and probes were sent to the moon. We had the early probes, the Rangers and the Surveyors, and then we had the manned missions that the Americans and the Russians were doing. We had Gemini, and then we had Apollo. Also going on at the same time were probes were being sent to other planets. And the early Mariner probes were being sent out to Venus and Mars in the early 60s. And from then on, right through the 60s and 70s, our view of the solar system began to become more enhanced. Not enlarged so much, but more enhanced. And here are several examples just to show how our change in perception of the inner solar system has happened. These were the exciting, on the top left there, the exciting Mariner pictures that came back in around about 1964 that showed that Mars didn't have canals after all. There was no vegetation there. It had craters like the moon, and it was very disappointing at first. We thought, oh my, Mars is a pretty dead place. And then the next set of Mariner spacecraft began to show more interesting things like canyons and that volcanoes were present. At least there were dead volcanoes. And then in 1976, in regard to Mars, a very exciting development was the first lander to send pictures from the surface of Mars. It wasn't necessarily the first lander. The Russians actually landed first in 1974. But in 1976, the Americans landed the Viking landers, and we began to see the surface of another planet. We had the surface of Mars. A lot of people tend to think that that was the first time, but no, the previous year in 1975, the Soviet Union managed to land a spacecraft onto the surface of Venus and brought back pictures of Venus. This yellow picture on the bottom left. This is sent back from Venera. There were, in fact, the first ones were in black and white in 1975. This example here was taken in 1982 on a later Venera mission showing basaltic rocks on the surface of Venus. And Venus has turned out to be a very, very different place from what we imagined it was. When I was a wee boy, Venus was thought to be a place that could well be habitable for life. It could well be that there might be an ocean there, and that the temperature, well, it was a lot hotter than the Earth, but it could be bearable for life. But when the first Mariner space probes went past Venus in the early 60s, in the mid-60s, 62 I think it was, and then the other ones, it showed that the temperature was very, very high indeed. In fact, so high that life couldn't really survive on the surface of Venus. A temperature that was hot enough to melt lead. And when the Veneras eventually brought back the first pictures from the surface, it turned out to be an extremely hostile environment where the temperature was more like 400 plus centigrade. The atmosphere was under extremely high pressure, about 100 times the pressure of the Earth. And not only that, it was corrosive. There was a lot of sulfur and sulfides in the atmosphere. So Venus has turned out to be a very, very hostile place after all. In stark contrast, Mars, with its pink sky, is much more likely a place that humans will land on when we eventually get there. The atmosphere is predominantly carbon dioxide, same as Venus, but is about 1/100th the pressure of the Earth. So Mars is a more easier place to explore. And what has happened since Viking, and especially since the 1990s, is there's been loads of spacecraft being sent to Mars. We've had another lander in 1997, the Sojourner, and then we had a fleet of orbiters sent in the late 90s and into the millennium. And then in 2004, we had the first of two very successful rovers, Spirit and Opportunity. And then we had Curiosity in 2012. And we're actually drilling into the rocks, and we're actually analysing what the rocks are made of. So here's a little drill mark made by the Curiosity rover. Meanwhile, we've seen the surface of the moon. Humans have been there. Some of us will remember the great Apollo missions. For those of you that are much younger, you might have seen last year the 50th anniversary programs on the lunar landings. For me personally, the thing that really fired my imagination was the Apollo 8 mission at the end of 1968. when humans actually went out to the moon for the first time. They didn't land, but they went all the way out there. I was able to really appreciate how much further astronauts had gone from what they had before, going all the way out 250,000 miles to the moon, and indeed going into orbit around the moon and then coming back. But then we had the landers to look forward to, and of course the great climax to that in July 1969, Neil Armstrong and Buzz Aldrin walked on the moon, and then there's been another 10 men walked on the moon since. Examples of the inner planets: Mercury. Mercury, here is an image of Mercury at the bottom right here. Mercury was not visited until 1974 and 75, when Mariner 10 made 3 flybys and showed that the surface of Mercury was very, very similar to the moon, except it's much more heavily accreted, and you expect that. And also, these flybys gave us an idea of the true mass of Mercury, and it turns out that it's a very, very dense planet indeed. And in fact, it's not that much less dense than the Earth. The Earth and Mercury are the 2 densest planets of the solar system. Since then, of course, we've had Messenger, which went into orbit, and we've now mapped the entire surface of Mercury, and we've now got Bepi Colombo to look forward to. Now, that's the inner solar system of planets. Of course, what was going on was the exploration of the outer solar system, and that began in the 70s with Pioneer 10, which flew out to Jupiter, followed by Pioneer 11, which flew past Jupiter in 1975, and then, 74, and then went on to Saturn and gave us our first rough images of Saturn in 1979. However, by then, 2 more better spacecraft had been launched in 1977, the Voyagers, and they really did open up our view of the outer solar system, the 4 giant planets, as Voyager 1 flew past Jupiter and then Saturn, and Voyager 2 flew past not only Jupiter and Saturn, but it went on to Uranus and on to Neptune. Uranus and Neptune before 1985 were just little blobs in the telescope. The best that we could do was we could see markings on the surface, but it wasn't until the spacecraft actually flew past these planets that we began to realize what they really looked like. And so our view of the solar system was completely changing because we were actually seeing what the planets looked like close up because of these spacecraft. Now, since the Voyages, we've had the Galileo orbiter at Jupiter, we've had the Cassini orbiter at Saturn, which I think personally was the most successful mission ever for the amount of data that's brought back, and for our revolutionize our views of the planet and its rings and its system of satellites. Not only did Cassini orbit Saturn and brought out lots of pictures, but attached to it there was the Huygens lander, which landed on Titan, the largest moon of Saturn. And just look at the picture there of what appears to be like rocks. Now, when you look at that, you think, my goodness, it's just like the Apollo pictures of the moon. It's just like the Venera pictures of Venus. It's just like the Viking pictures of Mars, except this is much, much further out. This is Titan orbiting Saturn, the furthest lander that's ever happened, that we've ever sent in the solar system so far. It's so cold out there that these rocks these boulders that we're actually looking at are not actually normal silicate rocks like you see in the inner solar system. They're actually ice, water ice. Water ice takes the place of the silicate rocks. It's so cold that the water ice is as hard as silicate rocks are on Earth. The temperature on Titan is near the triple point of methane. So methane behaves in the same way that water behaves on Earth. So it exists as a liquid, as a gas, and as a solid. So in fact, the weathering effects that you get, you can get weather on Titan caused by the methane cycles, have caused the weathering of the ice rocks here, pictured by the Huygens lander. Voyager brought back pictures of Triton, the large moon of Neptune, and what an amazing surprise was that there were geysers erupting from the surface of Triton. In other words, there's activity happening as far out as Triton. We'd already been surprised when Voyager flew past Jupiter, when we saw volcanism on one of the Galilean satellites, Io. To see volcanism happening so far out in the solar system on Triton was quite a revelation. Galileo Cassini flew past Titan on several occasions and used radar to map the surface. Now, Titan has a thick, opaque atmosphere similar to the atmosphere of Venus. So radar was used in the same way that radar was used at Venus with the Magellan spacecraft to show up features on the surface. So this is just a kind of quick overview as to what's happening, and it is still happening today. Just to think about minor bodies. Well, before I go into minor bodies, I'll talk about some of the moons. Because of the spacecraft that have flown out to the outer planets, all or most of the moons, of the many moons of the outer planets have been viewed, and they all have their own personalities. And this just gives you an idea. We can now match them to scale, and we can get a picture of what they're like. And we know their masses, so we get a picture of what they feel like if you could weigh them, and their densities and what they're made of. So what's happened is that the science of planetary astronomy, of planetology, has advanced quite significantly in the last 3 or 4 decades. These are the moons of the solar system to scale. You see actually that our own moon, the Earth's moon, is one of the 7 largest moons of the solar system. So we've got the Earth's moon, we've got the 4 giant moons of Jupiter, the Galilean satellites. We've got the large moon of Saturn, Titan, and we've got the large moon of Neptune, Triton. And then there's a clutch of medium-sized moons, like the 4 main moons of Uranus, Ariel, Umbriel, Titania, and Oberon. Several moons of Saturn, Tethys, Dione, Rhea, Iapetus, and in fact Pluto's moon, Charon. Now, that's another thing that I'm going to be talking about. What happened in 1977? Well, here we go. I'll just show this quickly, just to let you know that what we can do now is we can show the objects in the solar system to scale, and we can compare. This is an early comparison, and as time went on, as we found out more about the sizes of bodies, we could extend it even further. And this is a more comprehensive comparison of terrestrial bodies in the solar system, mainly moons, but a couple of planets, or 3 planets, or 4 planets, depending on whether you include Pluto and Eris, to scale. You see that Mars is half the size of the Earth, so we can fit Mars in there. Ganymede is the largest moon in the solar system. Titan's the second largest. The planet Mercury comes next in size, but Mercury is 2.5 times more dense than these bodies. So Mercury is still a lot more heavier than Ganymede, Titan, and Callisto. And then you've got Io. Io is a tad larger than the Earth's moon. The Earth's moon is a tad larger than the interesting Jovian moon Europa, which is the first evidence of a global ocean on another body in the solar system. And then we've got Triton at Neptune, etc. Now these are comparisons of 2 dwarf planets that I'm going to be talking about in a second. Before I do that, though, I'll just mention that the planets and their moons were not the only objects in the solar system that have been under scrutiny by spacecraft in the last 3 or 4 decades. I well remember when Galileo and Cassini flew out Jupiter and Saturn, they flew past the asteroid belt, and we got glimpses of asteroids for the first time. Small, rocky bodies, irregular in shape. We already had an inclination of what these bodies were going to be looking like, because way back in 1969, when Mariner arrived at Mars, it pointed its cameras at the 2 moons of Mars. Now, they're small, tiny moons, and they are similar to asteroids. I actually argue that Deimos and Phobos probably are not asteroids. I would argue that they're probably captured comets. Because how do you capture an asteroid? It's dynamically difficult to capture an asteroid, but it's much easier to capture a comet, because comets can outgas on impact and they can have their velocity changed. So I would argue that Deimos and Phobos at Mars, and a lot of the small outer moons of Jupiter, Saturn, Uranus, and Neptune are possibly captured comets that have been captured in the last 4 billion years, rather than captured rocky bodies. We'll find that a lot of these bodies are icy. Here's a small sample of more recent objects. Here's Eros, which was the first asteroid to have a lander. The craft got there and photographed it as it was rotating, got a good view, good pictures of it, and then they homed it in onto the surface and it gently landed. And I thought it was a fantastic achievement to actually land a spacecraft on an asteroid. Of course, asteroids are so small that their gravity is so feeble, but you can still do it. You can still gently land onto the surface. Here's another example of a tiny little asteroid called Ryugu. And look how irregularly shaped it is. It's like a lozenge. And here we have Itukowa, which was visited by the Japanese spacecraft. And it's just a pile of rubble. It's just a rubble pile. It's just a few hundred meters across. Very, very small indeed. Also, recently, an asteroid called Bennu has been visited and has been looked up in close range. And this is a very, very close-up view of Bennu, and you can see there's grains on the surface. And of course, comets. Well, I remember way back in 1986 when Halley's Comet made its return. Now, when I was a wee boy in the 60s, Halley's Comet, last seen in 1910, will next be seen in 1986. And I thought, my God, that's way in the future. You know, it came, it went. Spacecraft were sent, and there was a fleet of spacecraft, but it was the European spacecraft that brought up the first close pictures of Halley's Comet. And since then, of course, there have been several other comets visited. In 2005, I forget the name of the spacecraft and the name of the comet, but there was a projectile aimed at one comet. And they were to observe the actual blast, and they observed the crater that was produced. And more recently, of course, we have Rosetta that went to the comet. Now, I'm not going to say the name of it, but I know it's 67P. And this is a picture of the comet. And it looks like 2 lobes stuck together. And when you look at bodies like that, you think, my goodness, it gives you clues as to how the solar system began to build up. That really the planets, everything in the solar system, ultimately built up from smaller bodies. And when you look at these comets and asteroids, you're looking at smaller bodies that are kind of glued together and have this very irregular shape. More on that later. Now, oh yeah, here's another example of some of these small bodies. And just to show you how varied in size the litter of the solar system, the asteroids are. This is the largest of the irregular bodies of the asteroid belt, the asteroid Vesta. Now, Ceres is bigger, I'll be talking about Ceres later, but it's now classed as a dwarf planet, and it looks like a dwarf planet. Vesta still looks, I would class that as a large monster asteroid, a planetesimal. But these are, to scale, some of the other asteroids that have been visited. There's Eros that I've talked about. The Galileo spacecraft to Jupiter flew past Ida and indeed found another orbiting piece of debris named Dactyl, which showed that even tiny small bodies can have orbiting satellites, can have moons. Gaspro was another that was flown by. And I talked about Itokawa. To scale, you wouldn't see it on this. It's so tiny. It's at the bottom there, at the bottom of the picture. There we are. I think the picture, as I said earlier, the mission for me that really, really brought me most pleasure and I think overall possibly was the most successful of all the missions was the Cassini mission to Saturn. And there was one picture that was taken. Sorry that the quality of this picture is not very good. I actually copied it. I copied it, downloaded it, and I put it onto so I think the copying process has kind of made the quality poorer. But you can actually download this quite easily, and you can expand it, and you can look at it carefully. What we're looking at is Saturn with the sun behind it. Saturn is occulting the sun. And not only do you see the rings being backlit and the reflection from the rings, the sunlight reflected off the rings being reflected onto the dark side of Saturn, as you can see here. But you can also see the other extended rings that Saturn actually has. There's the F ring and the G ring. Oh, sorry, I guess the E ring. And these outer rings are associated with the satellite, the inner satellite system. And indeed, there's another dust lane much, much further out that's associated with some of the outer satellites of Saturn. But what was amazing about this particular picture, and I would ask you to download it and have a look at it, is you are looking not only at the inner Saturnian system, but because the sun is right behind Saturn, you're actually looking at the inner solar system as well. And what came up on this image were the planets Venus, Mars, and the Earth-Moon system, the Earth and the Moon together, you know. I think Mercury might have been behind Saturn or too close to the sun to see. But what a mission that was. But anyway, let's go back to the beginning again. The very first slide that I showed you was that one that was made 100 years ago, that picture from Artemis Encyclopedias, the Earth and its neighbours. And that's what children 100 years ago were seeing, were interested in, were actually looking at. This is what fired their interest, and indeed even my interest about 50 years later. Kids nowadays, if they're looking at pictures of the solar system, will see something like this. So they see the planets as they actually look, because of the spacecraft, because of the Voyager mission, because of the other spacecraft. So we've got, you know, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Pluto's still included, look. And there's the diagram of the solar system. We've still got this confined asteroid belt, you see. The inner solar system going around the sun, the outer planets more spread out, and then little Pluto right on the edge there. Now, 1977. I was getting a bit frustrated in the 70s because nothing exciting, no exciting ground-based discoveries seemed to be happening, apart from the odd extra moon was discovered at Jupiter. Yeah, so when I first learned about how many moons did Jupiter have, I was told, oh, 11. And then I discovered in 1972, I think it was, there was a 12th moon discovered. And then there was a couple more tiny moons discovered in the mid-70s. That was exciting enough. But what happened in 1977? Things began to change, you know. The first thing that happened that really excited me was rings were discovered at Uranus, that Saturn wasn't the only ringed planet in the solar system. Apparently, the planet Uranus passed in front of a star, and it was observed, and there was two dips in the starlight either side of the occultation, and the dips showed that there was several hoops of rings, dark rings, surrounding the planet Uranus. And then another interesting discovery was made later that year, in October 1977. A little planet was discovered orbiting between Uranus and Saturn, and the media went wild. Planet 10, you know. Well, apparently it wasn't big enough really to be a planet. It only turned out to be about 300 miles in diameter, but it was a small world. And it was the first of a new category of world to be known as centaurs. And centaurs are objects that orbit the sun in between the giant planets, anywhere between Jupiter and Neptune. Now, they're too small to be classed as planets or dwarf planets. They're too big to be simply dismissed as massive comets, because they're like small worlds in their own right. And they're too icy, that their nature is so different for them to be classed as outer asteroids. We didn't class them as asteroids, so we call them centaurs, because they were a mixture of various different kinds of bodies. And the other development that happened at that time was in 1978, when an image of Pluto was looked at, and it showed to have a bulge on it. And on further analysis, this bulge seemed to be moving round Pluto, and it turned out to be Pluto's largest moon, Charon. And that was really exciting, because up until then, if you looked at an astronomy textbook, number of moons, a table of planets, number of moons, Pluto, 0. So, and then suddenly we discover a moon around Pluto. And it turned out that this moon was quite large in relation to Pluto. And this was the beginning of Pluto's downfall as a major planet, because by observing how long it took for Charon to orbit around Pluto, we could calculate the mass of Pluto. Now, it's been downgraded since its discovery in 1930. In 1930, they knew straight away that it wasn't a giant planet. They thought it's probably about the size of the Earth, or maybe a bit smaller, maybe about the size of Mars. And then the general idea about Pluto in the 1960s was, we don't know its exact size, but it's anywhere between the size of Mars and the size of the Earth's moon. If it's the size of Mars, then it's very, very dark and very icy. And what we're looking at is the reflection of sunlight from the center of the disk of Pluto. If it's the size of the moon, or possibly smaller, then Pluto's reflectivity, or albedo, is higher, and it's quite shiny. So we didn't really know how big Pluto actually was. And then in 1968, Pluto occulted a star, a measurement was made, and it turned out that the planet was in fact even smaller than the Earth's moon. So it was looking like as though, yes, Pluto is definitely the smallest planet in the solar system. It's possibly maybe about 3/4 or even less the diameter of Mercury. But then in 1978, when Charon was discovered, we could then calculate the mass of Pluto, and it turned out, by estimating its size and its mass, its density would be only about twice that of water. So Pluto turns out to be a low density planet, and hence a new category of planet, what you call the ice dwarf planet. Now, this picture here is interesting. This is by the Dutch artist Escher, and Escher is a draftsman, amazing pictures. All these funny kind of impossible kind of situations. what I find interesting about this are the objects that are in the sky. So straight away, you can notice, oh yeah, that must be Saturn, you see. It's got the broad rings, the obvious rings of Saturn. So that's Saturn. There's a galaxy. There's a comet. There's another dark planet. I don't know what that could be. It could be anything, really. And there's another brighter planet. That could be Earth, maybe, or whatever. And this one here is obviously Jupiter, because it looks like Jupiter and it's got the 4 Galilean satellites. Now, what amazed me was this one here. There's a planet and there's rings around it. And these rings look exactly like the rings around the planet Uranus. And I thought, isn't that amazing? That's just like Uranus. The only difference is this was produced over a century before the rings of Uranus were actually discovered. So it's like as though Escher was having a kind of premonition about planets that were looking like Uranus, that there was more than one ringed planet than Saturn. Apparently, there are 4 ringed planets now. Of course, Voyager discovered rings around Jupiter. Rings were suspected around Neptune, and they were confirmed also by Voyager. And the rings around Uranus were discovered by occultation. So that's really interesting. So what about poor Pluto? Well, I mentioned about its demotion. Its size, it had been downgraded in size, it had been downgraded in mass, but it was still isolated. It was still on its own. It was still the only object beyond Neptune. So, and it was still a sizable planet. It was still the 9th planet. But then in 1992, we began to discover more objects beyond Neptune. Now, the Kuiper belt is a belt of icy bodies that lies similar to the asteroid belt that lies beyond Neptune, and it was predicted to exist by Kuiper, Whipple, Edgeworth, by various people. And in 1992 onwards, we started to discover a lot of these objects. The first objects that were discovered were small objects similar to the Centaur that I mentioned, that was discovered in 77, which, by the way, was called Chiron. And since then, there have been more centaurs discovered. So by the early millennium, the number of bodies in the Kuiper belt increased. The number of centaurs increased. And then we started to discover bodies in the Kuiper belt that were really like small planets, that were really a fraction of the size of Pluto. We discovered the first one to be discovered that was larger than Ceres. And then there was the first one to be discovered that was larger than Charon and half the size of Pluto. And then in 2006, 3 objects were announced. One was actually discovered in 2003, but it wasn't announced until 2006. Sorry, 2005, beg your pardon. 3 objects, one of which turned out to be comparable to Pluto, and the other 2 that was slightly smaller than Pluto, about 3/4 the size of Pluto. And they were named Makemake, Haumea, and Eris. And Eris, in particular, was very interesting because it turned out that this planet, we looked upon it when it was announced as the 10th planet for a while. There was a moon discovered around it, so we could actually calculate its mass. Its mass turned out to be 28% more than Pluto, but about the same size as Pluto. It's like Pluto's twin. And so for a couple of years, my dream from the 60s actually happened. Planet 10, we had a 10-planet solar system. But it was kind of spoiled by the fact that there was other planets that were slightly smaller. And so the International Astronomical Union decided that, Pluto is really part of this belt. It really happens to be the largest member of this belt of bodies that lies beyond Neptune. So shouldn't Pluto kind of be demoted as not being a planet to a new kind of object called a dwarf planet? And that we can also include Makemake and Haumea and Eris and even Ceres. And possibly a lot more of these Kuiper Belt objects that we've discovered. Just call them dwarf planets, because it looks as though, as more and more of these objects are going to be found, the solar system, if we're going to be talking about how many planets are there in the solar system, we've got to draw the line at a certain point. And so we draw it back to the original 8 planets before 1930. So poor Pluto, I felt sorry for Pluto. I still do. So the picture of the solar system then from 2006 onwards for kids is, well, you've got the 4 rocky planets, Mercury, Venus, Earth, Mars. The moon is given a kind of extra curious, if you like, because it's like a 5th major body in the inner solar system, but it's not a planet, it's a planetary satellite. We've got the asteroid belt. There's only one object in the asteroid belt which we can class as like a little planet, a dwarf planet, and that's Ceres. Then we've got the 4 giant planets with all their moons and satellites, comets as well. Pluto has this special place, but it's not classed as a major planet, as this diagram represents, because it's not got its orbit marked in, you see. It's like as though, oh, it's an extension of the Kuiper Belt. And there's Eris, and there's Makemake. Incidentally, Eris spends most of its time way beyond the Kuiper Belt. It's not really a Kuiper Belt object. I'll talk about that later. And here's some of these objects discovered in the Kuiper Belt shown to scale. There's Eris and Pluto, with Pluto's moon Charon. The Pluto-Charon system is more like a double planet because the center of gravity of the system is outside Pluto. It turns out that Pluto has got even more moons. When this diagram was made, 2 more were discovered, which were known as Styx and, whoops, sorry, I'll go back. Styx and Hydra, and then Nix and Kerberos was discovered later on. Makemake apparently doesn't have any satellites, so we're not really sure about its true size or mass. And Haumea actually has 2 moons orbiting it, but its shape is rather strange. It's more like a rugby ball, and it could actually be the merger of 2 bodies. 2 bodies that were closely in orbit around each other that eventually merged several tens or hundreds of millions of years ago, and creating this kind of object. Eris's moon is called Dysnomia, and it's a reasonably sized object. And here's some of the more interesting objects. Varuna was the one which was the first one to be discovered in the Kuiper Belt that was larger than Ceres. Quawa was the first Kuiper Belt object that was in a regular orbit. Its orbit was in the main plane of the solar system, and it had a low eccentricity. Orcus was an object that was announced the same month as Sedna in March 2003. Sedna turns out to be an exceptional body, which we'll talk about in a second. Here's some of the dwarf planets to scale with the Earth, just to show you how small they are. This is Eris. This is Pluto and its moon Charon, and this is Ceres. And as you can see from these diagrams, this is pre-2015, before we actually saw what these bodies looked like in close-up with the Dawn mission and the New Horizons mission, which we'll talk about in a minute. Now, other developments beyond the Kuiper Belt. I mentioned Sedna. Sedna was discovered in 2003, and what an orbit that it had. It was discovered to be way beyond the Kuiper Belt, about almost 3 times further away from the sun than Neptune. And when the planet was observed, it was observed to be moving such that it was at its closest point to the sun. In other words, its perihelion point, near enough. And its orbit was eventually mapped, and it turned out that it went out to about 900 times further away from the sun than the Earth is from the sun, 900 astronomical units. So we were beginning to see that the outer solar system was a lot more interesting than simply the Kuiper Belt. Other objects of this kind were discovered, and this has been extended further in the last couple of years towards an interesting conclusion that several of these objects seem to share a common orbit, and they seem to suggest, by an analysis of orbital dynamics, that the question arises, what placed them into those orbits? What could place them into a perihelion that's about 2 or 3 times further away from the Sun than Neptune? That could only happen by the interaction of a major body. So this leads to a question as to what body would have placed these objects into those orbits. Now, there's 2 main theories. One is that there is, in fact, another major planet out there, which is possibly a giant, a small giant maybe, a mini Neptune or a super Earth. And this has been dubbed as Planet 9, and it's been searched for, but we haven't found it yet. There may be more than one of these objects. If it does exist out there, it's probably in a highly eccentric orbit, and it's probably at its furthest point from the Sun at this present moment, which is the reason why we can't see it. So the other theory is that maybe these bodies were scattered billions of years ago when the Sun actually passed very, very close to another star as the Sun passes through the galaxy. Or maybe when the Sun was formed in the original cradle, stellar cradle that the Sun formed in, where other stars interacted and tore away some of the bodies. Maybe bodies like Sedna and this other object may have come from the other stars, and that the Sun has captured them. Very interesting to speculate on these things. So our views changed quite dramatically since my comfortable view in the 1960s and the early 70s of the 9 planets. It's not so much the Sun and 9 planets with their moons and asteroid belt anymore. I like to think of the solar system as being a 12-planet solar system, where you have the 8 major planets and you have 4 significant planets. And these planets are highlighted in red. So we've got the 4 inner terrestrial planets, Mercury, Venus, Earth, Mars. We've got the 4 giant outer planets, Jupiter, Saturn, Uranus, and Neptune. We've got the next largest planet, the next 2 largest planets, Pluto and Eris, where Pluto is the dominant body of the Kuiper belt, and Eris is part of a system of bodies called the scattered disk, which are bodies that come into the Kuiper belt when they're closest to the Sun, but spend most of their time way beyond the Kuiper belt. And then I've also gave Kuros to Ceres and Sedna, even though these bodies are not the next largest, because Ceres is the only dwarf planet in the asteroid belt. It's the only object that looks like a little planet in the asteroid belt. And Sedna is the largest known of the extended scattered disk objects that orbit, such that the perihelion, or closest point to the Sun, is way beyond the Kuiper belt that I just talked about a wee while ago. So we've got the Sun. It's possible that there could be a belt of debris inside the orbit of Mercury. Dynamics suggests that, but it might be composed of small bodies, no bigger than a few meters. So there's no way we'll be able to detect them by transit across the Sun. There's no way we'll be able to detect them even by spacecraft, unless we can measure infrared radiation coming from some of these bodies, but that would be quite a challenge. As yet, there's no evidence that there is a volcanoid belt. The only bodies that we have actually seen in that region are comets that come in from further out. I've gave significance to the Moon because the Earth-Moon, even though it's not a double planet, because the center of gravity is inside the Earth-Moon is dynamically and it's planetologically. The Moon is like another planet. It's like the 5th in the solar system's 5th planet. And then we've got Jupiter, Saturn, Uranus, and Neptune are really systems. They've got systems of rings and lots of satellites, different kinds of satellites, regular satellites, outer irregular satellites and inner fragments of rings, planets, satellites that are associated with rings. Then we've got the Kuiper belt, the scattered disk, the extended scattered disk, which could be the innermost part of the cloud of icy comets that is believed to exist in a shell right around the solar system known as the Oort cloud. And then, of course, we've got the comets, which could be anywhere from inside the orbit of Mercury to way out to the Oort cloud. And then we've got the centaurs, these bodies that I talked about, which are too small to be dwarf planets, too large to be comets, and too icy to be classed as asteroids. And they lie in between Jupiter and Neptune, and are probably the evolutionary story of centaurs is that they could be, in fact, in transit. They could have come from outside, from the Kuiper belt, and they're moving inwards, or the other way around. It could well be that Ceres, for example, might have been a centaur at one time that came into the inner solar system. It's all speculation. So I'm just going to finish off quickly by talking about the last exciting developments in exploration, which were in 2015, while we're on the subject of dwarf planets. And that was Ceres, the Dawn mission to Ceres, and the New Horizons to Pluto. This is an artist's impression of Dawn on its way to Ceres. Before it went to Ceres, of course, it went to Vesta, the large asteroid. Before Dawn, this was the best image of Ceres that we had, taken with the Hubble Space Telescope. And I've superimposed it on with the Moon and the Earth, just to give you an idea of a comparison of size. A rather respectable sized body, and it's certainly very, very smooth and circular. A dwarf planet, a small dwarf planet, rather than a large asteroid. About the size of France, maybe a bit bigger. And its orbit is entirely, of course, in between Mars and Jupiter. And I'm not going to go into too much detail. Its orbit is a little bit inclined. It's right at the center of the asteroid belt. And in fact, the planet's orbits are kind of like a geometric series, and Ceres actually fills in the gap. When it was discovered in 1901, it filled in the gap nicely, because it was the reason how it was discovered in the first place, because they were trying to hunt the missing planet between Mars and Jupiter that would fit the gap. And they found it in 1801 on January the 1st. But then in the next few years, they discovered Vesta, Juno, and Juno, Vesta, and Pallas. They discovered 4 more. So suddenly Ceres was classed as a planet for a brief while, and then it lost its planetary status. And then as more and more asteroids were discovered after 1845, it just got relegated to asteroid. But then again, in 2006, it's now being brought back up to the status of a dwarf planet. And this is more images with the Hubble Space Telescope of Ceres, showing a mysterious bright object that was on the surface. I can see we'll run out of time, so I'll just quickly. This just goes, emphasizes how special Ceres is in the asteroid belt, comparing it with Vesta, which is the largest of the asteroids. I think Pallas might actually be slightly smaller than Vesta. It's a very dark object. It's further out. We've not visited it yet by spacecraft. But we can see another comparison of these bodies with 2 planets in the Earth's moons. We've got Mars, Mercury, the Moon, the dwarf planet Ceres, and the large asteroid Vesta, planet, or planetoid if you want to call it that. And it's believed that Ceres was possibly water ice, a mantle of water ice with a rocky inner core and a thin dusty outer crust, which was proven correct actually when Dawn got there. So Dawn actually got there. I'll talk about the end result in a minute. I'll just go into Pluto. The mission to Pluto in the same year, 2015, was New Horizons, launched in 2006, the very year in which Pluto lost its planetary status. Again, believed to be a low density, because it's a low density body, it's believed to be a mantle of mainly water ice. Very low surface gravity. Up until New Horizons, the best images we got were of Hubble Space Telescope. That's the best ground-based, which was an improvement on the discovery in 1978 of the moon Charon. And then Hubble Space Telescope can split Charon and Pluto. And then in the years after 2006, exciting discoveries at Pluto with the Hubble Space Telescope. Pluto, Charon. First of all, there was the discovery of, where is it now? Not Kerberos. Was it Nix and Hydra? Yeah, Nix and Hydra were discovered first. And then a couple of years later, the two fainter ones, Styx and Kerberos. And really exciting, because for a dwarf planet, you know, it certainly punches above its weight. I mean, you consider Venus and Mercury have no moons, but Pluto has at least 5 moons. Boasts a system in its own right. Although, because Charon comparable in size, we talk about the center of gravity of the system. So, in fact, Pluto actually orbits the center of gravity of the system. So, as Charon is going around Pluto like this, Pluto is going around like that, and the center of gravity is in the middle. New Horizons was launched at the beginning of 2006, yeah. And this diagram was when it had arrived at the orbit of Uranus, and it was going to go on out towards Pluto. So the trajectory, at this point, Pluto was here. By the time the spacecraft got to here, Pluto will have moved on to here. And one of the things that scientists were worried about at New Horizons was that perhaps these 4 small moons that were discovered were in fact the brighter members of a ring of debris around Pluto. Possibly the Pluto-Charon system, when it formed, may have formed through a collision, and a lot of debris was formed, and it formed an extensive ring system. Now, up until recently, we've only been used to ring systems around giant planets, and it became a kind of norm until you thought, well, why not have ring systems around smaller planets? Obviously, ring systems around the inner planets don't seem real because, well, how could they have formed? Maybe in the early epoch of the solar system, the Earth, Mars, Venus maybe had temporary ring systems that eventually, certainly at the time the moon was formed around the Earth probably had a temporary ring system. But the idea of a ring system around Pluto cottoned on for a while, and it became concerning to scientists of New Horizons as to how the probe was going to survive the system, if it was going to get through, because it was hoped, you see, that the probe would go on further into the Kuiper Belt, which it did, which I'll talk about in a second. So it got through the system quite safely, and it showed that, well, this is Pluto as the significant characteristic of Pluto that stands out when people think about that flyby is this heart shape, which is now named after Clyde Tombaugh, the discoverer of Pluto. I remember just weeks before the flyby when we began to see dark patches on the surface, and it was very, very exciting, and you could see Charon orbiting. And then as we were approaching closest approach, this heart shape came into sharper focus. And then we flew past it, and we got a real close-up view of the surface of Pluto, and we could see that there were all sorts of terrain. That this area here was in fact very, very smooth and devoid of craters. In other words, very, very young. And it turns out it's nitrogen, frozen nitrogen. At that temperature, it's like a soft snow. There was also lots of methane compounds and other carbon-rich compounds on the surface. and the atmosphere turned out to be quite thicker than expected. And it was all very, very surprising. Even Charon itself turned out to be a surprising body as well, a very richly cratered, icy body. Here's a picture of the same year of Ceres taken with Dawn, and there's that bright object, which turned out, and you can download this and have a look at this in close-up, just turns out to be a couple of patches of halite-like salt structures, which have such a much higher albedo than the rest of the icy surface, the dusty and icy surface. But 2015 was very, very exciting, you know, for the outer solar system and for the asteroid belt. Talking about rings, one of the other discoveries made was a ring system around a minor body. Now, I talked about the very first centaur, Chiron. Well, since then, there have been several other centaurs discovered, orbiting between Jupiter and Neptune. And I think the second largest one is called Chariklo. Can I pronounce it? Chariklo. And a few years ago, it occulted a star. And it turned out that it's got a ring system. Now, this body is only about 200 miles across. It's only about 300 kilometers in diameter. It's a very, very minor body. It's not even classed as a dwarf planet because it's too small to be a dwarf planet. It's comparable in size, you know, with Saturn's moon Enceladus. You know, the one that surprised us with the geysers and the possibility that there's life there. You know, that's another story. You can talk about all sorts of things on this. But that to me was amazing. So the rings must be a lot more common in minor bodies than we think. Now, Eris, what I thought and classed as the 10th planet in 2006, until it got demoted to dwarf planet. This is its orbit, and as I said, it's really it's not a Kuiper belt object. It's a scattered disk object, but its orbit is highly eccentric. It's highly inclined at about 40 odd degrees, 44 degrees, and more extreme than Pluto in many respects. And I'm optimistic that in the next few decades, we'll actually discover more and more of these kind of objects in the outer solar system, objects that are even larger than Pluto. And we might even discover an icy body way beyond the Kuiper belt that might be about the size of Mars, the mass of Mercury, and the density of Pluto. In other words, a giant version of Callisto. But I'm optimistic that even further out, there is that Planet 9 that is responsible for the eccentricities of some of these far-flung objects. Artist's impression of what Eris looks like. It believes its albedo is very high because it's relatively bright for its distance, at magnitude 19, I think it is. And it's about 3 times further away from the sun than Neptune. But currently it's around about its aphelion, furthest point from the sun. So in about 2.5 centuries, it's going to come into the Kuiper belt. And it'll be a lot brighter than Pluto. Its brightness will increase to about the 12th magnitude. So way back in the early 1700s, Eris was about the 12th magnitude. That's the last time it was in the Kuiper belt. And this is a Hubble Space Telescope taken of Eris with the discovery of Dysnomia, which the satellite, the moon, there's probably more moons there. It's probably similar to Pluto in many respects. And it was because of the observations made of the timing of the period, the orbit of the moon around Eris, that helped us to determine the mass. And of course, it's about 28% more massive than Pluto. It's about the same size as Pluto. Could actually be slightly smaller, which means it's denser than Pluto, which means it's more rocky and less icy, which is interesting for a body so far away. Artist's impression of Sedna. Now, when Sedna was discovered, it was assumed, oh, it must have a moon. Why? Well, it seemed to show, the spectrum seemed to show that its rotation was very, very slow. That it might have been in a locked synchronous rotation with a relatively large satellite. But strangely enough, no large satellite has been discovered yet at Sedna. So this artist's impression is a bit misleading. But it turned out that the Sedna is very, very red, even redder than Mars. And it's a small planet, about 2/3 to 3/4 the diameter of Pluto. And as I say, its closest point to the Sun is about 3 times further away than Neptune, and it ventures way out, 900 times further away from the Sun than the Earth. And that's about 1,000th the way to the nearest star, which is really interesting. Now, I mentioned about New Horizons, and it flew past Pluto in 2015, and it was due to go into the Kuiper Belt, but they had to find a body to go to. Eventually they did. The body was nicknamed Ultima Thule, and eventually New Horizons quickly flew past it. Very, very small body, only a few tens of kilometers across. And when they got there on January the 1st last year, 2019, it turned out to be like 2 bodies stuck together. Its proper name now is Arakoth. And amazingly, this object in the middle of the Kuiper Belt is as far away from Pluto as Saturn is from the Sun. So, and when you think about it, it's absolutely amazing. And it flew past so quickly that it took time for the images to come back. If you look carefully, you're looking at bodies, not just 2 bodies that had merged together, but you're actually looking at lots of bodies that merged many, many billions of years ago, because there seems to be evidence that there's lots of smaller bodies that have kind of merged together before the 2 main bodies came together, you know. And look, there's craters, amazing. Cratering suggests that there was debris, so there was debris out there as well, you know. And this is in the middle of the Kuiper Belt. And hopefully, I hope that New Horizons will find another Kuiper Belt object further out to get to. This is the final slide. It's just to emphasize that, you know, the solar system is a very, very interesting place. We've got the main planets, the main planetary plane from Mercury all the way to Neptune. And then we've got the Kuiper Belt with its dwarf planets. But goodness knows what we've got further out. And, you know, as I said before, I'm just hoping that we will discover something really, really significant, something that's so significant we can call it our 9th proper planet. Now, I think that is the end. So I'll go back to that. And if anybody's got any questions, I'll only be too happy to try and answer them. Nothing too technical though.
Graham, thank you very much for a fascinating and very detailed talk. It was truly an excellent piece of work. We've got quite a few questions. I'll start with one from Eric, and it goes: which solar system planet moon do you think is most likely to harbour some form of organic life, and what form do you think that life will be?
That's a difficult one, because I'm optimistic about Europa. It's almost 100% certain that there's a liquid ocean underneath that icy crust on the surface of Europa, and it's possible that life could have formed of. I don't know if it'll be carbon-based. It might be silicon-based, and it's very, very interesting because even carbon-based bacteria, there are these extremophiles now found on Earth that can exist in extremely cold environments and extremely hot environments, like beside vents on the ocean floor under extreme pressure and extreme temperature. I think Europa, but I'm also very optimistic about possibly that Enceladus may have, even though Enceladus is such a tiny body. You know, Enceladus is only about the size of Scotland. It's only about 300 miles across. I'm optimistic that they could be extremophile, carbon-based extremophiles, maybe on Titan. There's also the possibility that there could be bacteria in, well, Mars. The question was about moons, wasn't it?
Yeah,
so
that's right. Yeah.
I just said Mars first, but I think out of the moons, the three that stand out most for me is Europa, Enceladus, and Titan, and that the form of the life is different on each of them. I think there are lakes on Titan. You need fluid. You need fluid of some kind for life. I think in the long term, and there is fluid on each of these bodies. I'm not sure about Ganymede, Callisto, whether there's oceans under there, or even Triton and Pluto, even. But yeah. Hopefully, we might find out in the next 20 years.
Great, yeah. Okay, question from Pete Sherman here. Do you think Jupiter will regain its place as the planet with the most moons?
Now, that's an interesting one, because in the last 10 years, one of the great developments has been the discovery of many more tiny satellites further out. They're called, I call them the irregular satellites. To me, they are those captured comets that I talked about. And I think, is it at the moment, is Saturn's got the most, isn't it? Is Saturn standing?
Yeah, I think Saturn currently holds the record, yeah. It's,
Saturn's at 80, isn't it? And is Jupiter at 78 or something?
it's a pretty close competition, I think, yeah, at the moment.
It's really an interesting history, that, the race between these planets as to who's got the most moons. Because it starts out, Jupiter had 4, Saturn had 1, and then Saturn had 5, but Jupiter still had 4. And then by the beginning of the 20th century, I think Jupiter had the most, and Saturn had 9 and Jupiter had 11, you know. And then, let's see, and then when Voyager flew by, I think both of them gained a few moons. But then the Hubble Space Telescope has discovered many more, much further out. Not only around Jupiter and Saturn, but many more at Neptune and Uranus as well. I suspect that Saturn may have more moons. And the reason why, not because Jupiter's more massive, but the thing is Saturn's much further out. And there's less perturbation from the sun. Because all these outer irregular moons orbiting Jupiter, their orbits are not ellipses, they're squashed ellipses. They've got variable eccentricity. There's a tug of war going on between the sun and Jupiter. Maybe in the long term, some of them may be temporary. I don't know. I'm not a dynamicist, but I suspect there would be. But I think that there is a zone around each of the planets whereby a satellite is stable. Outside that zone, then the sun is going to have a greater influence, depending on the relative velocity. But that'll shape the orbit. And I think Saturn has the best, has the optimum distance and size to have the most moons. But then again, another factor is debris picked up. As I've said, I think a lot of these outer moons are captured comets. You can capture comets, but you can't really capture asteroids. To capture an asteroid, it has to hit something, but it might shatter the asteroid. For a comet to be captured, all it has to do is to outgas by being hit by a small meteoroid, and it changes its velocity. And if it happens to do that near a giant planet, it's going to go into orbit around the planet. And there's been 4.5 billion years for that to happen. So I think a lot of these small satellites orbiting the giant planets are captured comets. And it could well be, there could be a more dense cluster of them nearer Saturn than Jupiter. We just don't know. We just got to keep watching.
Yeah, well, it's great, isn't it, to give us something to watch. It's hey, we've got another question from Pete here, and it is: are there any missions planned for the moons of the solar system to search for life?
I'm not exactly sure about that. What's happened? I think the Juice mission is planned, isn't it? What is that? I'm not sure. Is that going to land on Europa or and if it is it going to drill into the ice?
I'm not sure. That's,
Not sure. I think only at the moment only NASA and ESA are capable of planning such missions. But you never know. In the next 10 years, the Chinese might be able to have enough technology to do these things. So I'm not sure. I hope so. I hope that we do have a taster of what is underneath that ice, or if we can land on Enceladus near the geysers, something like that. Yeah.
good. Okay, it's I can see that. Yeah, those moons around Saturn and that do intrigue you a lot, and that sort of leads on to a question from myself, really. What body in the solar system do you find the most intriguing?
The most intriguing.
Yes, the most enigmatic or whatever.
Oh, that's so difficult. It's also like asking me which piece from Holst's Planet Suite you like the most. I like them all. They're all different. They're like a family. I mean, they are my family. My other family. The Earth, our own planet, actually, is the strangest of all the planets in the solar system. It's saturated in life, complex life. It's at the triple point of water. It's got plate tectonics. It's got a relatively large moon, a planet-sized moon, and it's only got one moon, and it really shouldn't be there. So the creation of the moon was a very unlikely event because of the dynamic situation. So out of all the planets, out of all the bodies in the solar system, the Earth. But as an astronomer, we look outwards. So the most beautiful one as a child, I loved Saturn. I was fascinated by Saturn. And then I was fascinated by Mars when we started landing on Mars with Viking, and then more recently with the rovers. I mean, Mars is so explored. It's like as though we've actually, it's like as though humans have actually been there. The Curiosity and the Sojourner and Opportunity and Spirit. And there's another one on its way. In fact, there's been three missions to Mars launched in the last 3 weeks. It's really, really fascinating. Mars, and then Pluto. Pluto's mysterious. And when New Horizons got there, it does punch above its weight. It deserves to get its planetary status back. I would like to think of it. I'd like to go back to the old days when it was the 9th planet and keep Eris as the 10th. But then that brings problems with the other ones. They'll complain. They'll want to be planets as well. I think if I have to choose one body in the entire solar system that I think is the most strangely interesting, it's Saturn's moon Titan, because it's got a thick atmosphere, as thick as the Earth's, the same constituent as the Earth, it's nitrogen, except everything is in deep freeze in relation to the Earth. It's much further out. But as far as methane is concerned, methane on Titan behaves in the same way that water behaves on the Earth. So you've got weather. It's the only other body in the solar system where you've got Earth-like weather. And when the Huygens lander was descending through the atmosphere, you saw views that reminded me of the Firth of Tay. It was absolutely amazing. God, that looks like the east coast of Scotland. But it's those lakes, and I think we have to go back to Titan. We've got to have a Titan orbiter, and we've got to have more Titan landers and balloons. We've got to send balloon missions into Titan's atmosphere, and we've got to search for life there, possibly. Search for anything that's interesting. Search for anything that's unusual, that might point to an unusual form of life that you wouldn't get on Earth. So I think Titan. It's got to be Titan. Enceladus is interesting. No, Titan.
I can see your tone here, Graham.
I
Hey,
think we
well,
might have to leave it there.
yeah,
We're
we'll
getting
take that,
running on a
yeah.
bit.
Yeah.
But to say the questions, there are still some questions I can see in the Q&A, but if you want to pop them in the chat, maybe Graham can pick them up from there. But that was a fantastic talk, Graham. To say the solar system getting much bigger than what we actually think it is, isn't it? That's for sure. Now, as I say, it was 10 years ago when you were up here last, wasn't it? We probably gave you, yeah.
10.
Let's say we probably gave you a little gift at that time. Now, you may have had a little paperweight if it was 10 years ago.
I can't remember. Yeah, I think it was. Yeah.
Yeah, that's good then, because we've got something new for you this time.
Oh.
It's a little whiskey glass. Well, not a little whiskey glass, a crystal whiskey glass with Sigma written on the front. So if you drop me a little email sometime with your address, we'll make sure we get this in the post to you. And maybe one day we can meet up and we'll have a drink together in it, with it.
Well, that'd be brilliant. Yeah.
Okay. It's just a little thank you for giving your time up for us for Sigma. Okay.
Okay, right. In the second half, we have Stuart doing the space news, and after that, we'll have Pete giving our first visit to the Murray Sky at night after the summer break, and then he'll also get talk a bit about club news after that. So what we'll do is we'll get Stuart queued up and ready to go with the space news. One thing I would say is if you've got any questions for Stuart in the Q&A, but to put them in the Q&A and we'll get them answered when Stuart's finished speaking. So over to you, Stuart.
Right. Okay, share my screen. Okay, does that come through okay?
That's perfect.
Right. When I started doing the space news 2 or 3 years ago, it was news actually by the time I came to present it. But nowadays, I go do a search on the internet, then find out the next day the article appears in the newspaper or on the news. So there's more awareness of what is happening in space. And so it's difficult to actually identify things that are new. But what I've done, oops, not moving. I've selected a few updates and a few new items just to go through it. Some of it you may have already seen on the news, but hopefully it's a summary of what has happened during the last month. Now, you may be all aware of that, which was the Boeing Starliner, which, if you remember, launched on its first test flight to the ISS on the 20th of December 2019. And during this uncrewed orbital flight test, it was intended to spend a week at the ISS before returning to Earth. However, it had to cut short its mission because of technical problems. And the initial results from the review they did of that by NASA and Boeing was an onboard timer drew incorrect time from the Atlas V rocket and failed to execute the orbit insertion burn needed to reach the ISS. There's also a temporary failure of the communications, which means they couldn't manually direct it to or command it to do the orbit insertion burn. By the time they managed to take control of it, it had used up so much fuel it couldn't actually get to the ISS. So it did two circuits of the Earth and landed. Now, follow up, earlier this year, a NASA review of the flawed test flight identified 61 corrective actions for Boeing to address. And on the 7th of July, NASA announced that the number had swelled by another 19 corrections for a total of 80 after a second review. And NASA has now completed its investigation into Boeing's problematic test flight. And Boeing announced in April, which is a few months back, that it will conduct a second uncrewed flight test with Starliner to demonstrate the spacecraft is safe and reliable. There's no date set for that yet, but when you look at the number of problems it's had, it's a bit worrying about the quality aspects of the company. And if you think back of the two 737 MAX aircraft that failed, also had safety problems, there must be something inherent in the company when you think what has happened here and what SpaceX has achieved. Right, the other one update, if you remember, the NASA's Mars mole, which wasn't actually driving down into the planet, was being assisted by the bucket on the end of the robotic probe, and they thought they'd solved the problem. It turns out that they haven't solved the problem. The mole is now set just below the surface, and they believe that the problem is caused by what they call, and I look at the duricrust, which is like a cement type powder, which is preventing the mole from actually digging itself in. At the moment, they can't see the hole or the mole itself very clearly because of the bucket that's there, and they have to move that, which takes a little while. In the next few weeks, they plan to do that. They're going to try and fill the hole with the soil that's around it to see if they can get more grip and get it to penetrate. The other problems that's happening at the moment, they've got to keep the solar panels clean because they're getting covered with dust as the climate changes as they approach the Mars winter. But the mole was provided by the German Aerospace Center as one of the two main science instruments on board. The other one is the seismometers, which have already detected 480 seismic signals, but that's dropping off slightly as the atmosphere changes and there's more vibration on around from the atmosphere, and that it's not picking up the smaller signals. The communication system is also detecting the exact position of the lander and therefore assessing the amount of wobble that's occurring as Mars goes around the sun. So there's a lot of good information coming back, but they still have a major problem with their mole. And this is what it's supposed to have achieved. It measures the thermal conductivity of the soil approximately every 50 centimeters up to a depth of 5 meters. So that's still yet to be achieved. Now, what has happened just recently was it was reported by the new US Space Command on the 23rd of July that Russia had tested on the 15th a space-based weapon system that can be hidden inside a large orbiting satellite, Cosmos, which happens to be Cosmos 2543, and emerged to fire projectiles, lasers, or microwave beams to destroy US satellites. And Cosmos 2543 had been seen flying near a US spy satellite before the test. And the satellite system used to conduct this test was also the same one that the US Space Force labeled as unusual and disturbing in February of this year, after 2 Russian satellites in the system, Cosmos 2542 and Cosmos 2543, followed a US spy satellite. It isn't clear how the Russians' anti-satellite weapon actually destroys an enemy satellite, and I use that in inverted commas. One way is to simply crash into the satellite. Another method is to explode what amounts to an orbital shotgun, a warhead packed with high explosives, designed to pepper enemy satellites with lethal metallic pellets. And the Russian Ministry of Defense did officially confirm that on the 15th of July, small inspector satellite, Cosmos 2543, conducted a close proximity evaluation of another Russian satellite, Cosmos 2535, in orbit. The Russian military stated that the inspection provided valuable information and images of the target vehicle, and the resulting information had been transmitted to ground stations. However, soon after the Russian announcement, the US Space Command published orbital data for an object, which they called 45915, which separated from Cosmos 2543 on the 15th of July at a considerable velocity relative to its host satellite. The newly discovered object was tracked and its origin linked to Cosmos 2543. And this clearly referred to the rendezvous between Cosmos 2543 and Cosmos 2535, which the Russians were made reference to. And this is an artist's impression of a shotgun type anti-satellite weapon. As you can see there, it's firing a cloud of fast moving pellets. And this is the launch pad in Russia where the modules were actually launched from. And this is, I took this from the Daily Mail because it actually gave a good view of how it was built up. Launched, as you can see there, I'll find the, right, it launched here by a Soyuz rocket, two combination satellites, which then, that's Cosmos 2542, separated into two, and this was 2543, which launched the weapon that the US forces picked up, which is interesting, that they're now taking the war to space and not trying to solve it on the ground, which is rather worrying. The other thing that has been in the news just recently was the ESA and NASA's solar orbiter. On the 19th of July, the orbiter returned its first data, and this is its closest so far pictures of the sun, which is about halfway between Earth and the sun. And it's an international collaboration between ESA and NASA to study the sun. And it was launched on the 9th of February this year and completed this first close pass in mid-June, and they've just downloaded the data. The images that have been received will help piece together the sun's atmospheric layers, which is important for understanding how it drives space weather near the Earth and throughout the solar system. And that's an artist's impression of it approaching the sun. There was some data that's been received showing features never observed in such detail before. The extreme ultraviolet images are dotted with what have been called campfires. It's not clear what they are, but they are about 1 million times smaller than solar flares, or even 1 billion times smaller. And it's thought it's possible they are mini explosions known as nanoflares, which help to heat up the sun's outer atmosphere, or corona, to its temperature 300 times hotter than the solar surface. And you can see here, the arrows actually pointed to these campfires. They're very small, but apparently there's a considerable amount of them that are causing this, what they believe is heating up the corona. It's the orbiter is not expected to get its closest point to the sun for another 2 years. Now, Graham's already mentioned the Mars missions, which there's been 3 of. 3 missions to Mars were planned and launched during July. There was the United Arab Emirates' first ever interplanetary effort, the Hope Mars mission, also known as Al Amal in Arabic. planned launch 14th of July and launched on the 20th of July. China's landmark launch of its first fully homegrown Mars mission, known as Tianwen-1 or Heavenly Quest, planned 23rd of July and launched 23rd of July. And there's the United States and Europe's launch of Perseverance, planned launch 30th of July and launched 30th of July. All three vehicles are due to reach Martian orbit next February, timed to coincide with a window of opportunity that comes around once every 26 months, when the two planets are in the most favorable alignment and the journey from Earth is shortest. Now, a little bit of history. Of 56 previous missions destined for Mars since the Soviet Union's first attempt in 1960, some of them planetary flybys, some orbiters, some landers and rovers, only 20 have fully succeeded. Some never even made it safely away from Earth, and Graham probably knows a lot more about this than I do. As we mentioned before, China's only previous attempt to reach Mars was in 2011 when it piggybacked a Mars probe, Yinghuo-1, on a Russian rocket. The spacecraft failed in Earth orbit and fell into the Pacific. Only the US and Russia have landed on Mars. Of 12 landing attempts, only 8 succeeded, all of them by NASA. Russia made it in 1971, but its spacecraft stopped communicating shortly after landing. Both the US and Russia, plus Japan, India, and the European Space Agency operate Mars orbiters. Now, looking at each one in turn, the HOPE orbiter is planned to reach Mars in February 2021, as they all are. It will use its 3 science instruments to study Mars' atmosphere, weather, and climate from above. And its aim is to help researchers better understand Mars' transition from a relatively warm and wet world to the cold desert planet known today. And the spacecraft was built by UAE's Mohammed bin Rashid Space Center in partnership with the University of Colorado Boulder in Arizona University and the University of California, Berkeley, or Berkeley as the Americans call it. And the probe was launched by a Japanese H-2A rocket from the Tanegashima Space Center in Japan. That's a photograph of the vehicle before it was launched. And that's the launch. And that is an outline of what it does. Its mission duration is 687 days. And its primary objective, new data about Mars climate and atmosphere. And it does 55 hours in a single orbit. And that is an artist's depiction of the UAE's HOPE mission orbiting Mars. It's a fairly basic mission, as they've mentioned, and said that one of the reasons they're trying to get into the space industry is that the UAE's revenue has come from oil, which is slowly depleting. They want to diversify, and they want to diversify into technology. And they've thought the best way to do that is to force the technology through space. China's Mars mission is a Long March 5 rocket, launched China National Space Administration's Taiwan Mars rover, lander, and orbiter from its coastal Wenchang Satellite Launch Center, which hopefully didn't drop anything in the sea or any other land area as previous ones have done. It's not only its first fully homegrown Mars mission, it's also the first to carry both a planetary orbiter and a rover. And again, we mentioned the fact that it's failed there. It'll reach Mars in February 21 and the same time as NASA's Perseverance and the United Arab Emirates HOPE orbiter. However, China's rover will remain attached to the orbiter for 2 to 3 months before attempting its landing. And the chosen landing area is Utopia Planitia. And I think this is what Graham mentioned as well about the NASA's Viking 2 lander touchdown in 1976 there. It's an old large impact area. And it's a landing area that they've been considering for some time. oops. The rover will investigate the surface soil characteristics and water ice distribution with its own subsurface exploration radar. It will also analyse surface material composition and characteristics of the Martian climate and environment on the surface. And the orbiter will operate in the polar orbit in order to map Mars's morphology and geological structure while using the Mars orbiting subsurface exploration radar instrument to investigate soil characteristics and water ice distribution. We'll also measure the ionosphere and electromagnetic and gravitational fields. Right, there's its launch. That again depicts its mission duration, 1 year, and the rover's 3 months. Primary objective to look for underground water and evidence of ancient life. And that again is an artist illustration of China's first Mars rover. Just take that off. The NASA's Mars mission, Perseverance rover, launched successfully on the 30th of July aboard a United Launch Alliance Atlas V rocket from the Complex 41 at Cape Canaveral. It'll take about 7 months to travel to Mars, and on the 18th of February 2021 will land in Mars, the Jezero crater, and it will search for signs of ancient microbial life, which will advance NASA's quest to explore the past habitability of Mars. It has a drill to collect core samples of Martian rock and soil, then store them in sealed tubes for pickup by future mission that could ferry them back to Earth for detailed analysis. I noticed they're using a drill there and not a mole, which is probably more sensible. It will also test technology to help pave the way for future human exploration to Mars, because NASA's main aim is to go to Mars. So a lot of what it's doing is to get more information for this Mars trip. And strapped to the underside of the rover for the journey to Mars is a technology demonstration Mars helicopter, Ingenuity, which may achieve a Wright brothers moment by testing the first powered flight on Mars. That's the launch. And that shows the Ingenuity helicopter. But if you notice, the altitude is 3 to 10 meters and flight time is only 2 to 3 minutes. So it's not going to go very far or very high in that time. But I suppose it gives it a height to actually look forward to see where the rover can go. And there's the rover. Now, Virgin Galactic, Richard Branson has said that he's now designed the tourist part of the Virgin Galactic for the space vehicle. He said he's designed that first and built the module around it so that the tourists get the best possible conditions. Unlike when the Navy built the ships, they built the ships, put the weapons in, and then tried to look for space to put the crew in. But they've actually done. It's quite impressive. So we go through what they've done. Individually sized reclining seats for G-force management and float zone volume. Automated mood lighting harmonizes with each flight phase. Personal seat back screens connect astronauts to live flight data. Cabin architecture facilitates effortless movement in weightlessness. 16 cameras provide high definition footage and stills. 12 cabin windows through which the astronauts can gaze at the Earth. And the largest mirror in a spaceship cabin mirror reflects the real-time astronaut experience. And that's what it looks like, which is quite impressive. Virgin Galactic has also tied up with Rolls-Royce, and I'll get for a business has a partnership with Rolls-Royce to develop a supersonic business jet to fly at 3 times the speed of sound, making the flight from London to New York only 90 minutes. And the aircraft on which NASA has also collaborated would fly between 9 and 19 passengers and crew at an altitude above 60,000 feet, according to the design unveiled on the 4th of August. So the Virgin Galactic seems to be moving well on, and as does SpaceX, but poor Boeing seems to be dropping behind a little bit. And in terms of SpaceX, I don't know if you remember that one. They had lots of problems with the Starship prototypes blowing up. They've actually launched one which has gone up to 150 meters, sorry, as it's taken off. I'm not sure whether it's more like a can of beans, but that's it during its 150-meter launch, and that's it landing straight back down again on the Starship pad. Now, it's, according to SpaceX, they're going to do a few more short hops before they then start putting the nose cone and all the other bits on and start flying some real launches. But that was SN5, and all the previous ones up to SN5 seem to get destroyed in some way or another. And just for the final bit, some local news. The spaceport near Tong in Sutherland has been given approval from the Scottish government, and so they think that the last I read was that the 2022 they should be launching their first satellites. So that's really the end of my talk. If you're happy with that.
Stuart, thank you very much for that. An excellent and informative piece. Just one question from Eric, and he said, whatever happened to this US Star Wars military weapon? And also, when and what did the Chinese do a few years back? Eric seems to remember that they also had an anti-satellite
Well, they did,
system.
didn't they? Yeah, I haven't got anything on that one, but they said the US report on the Russian one, they don't know where it went. It just disappeared in space, but they actually monitored it, leaving the space module some quite high velocity. So it was obviously it wasn't two space modules coming together to have an inspection. It was sending something quite fast.
Yeah. Okay.
I'll have a look to see what the Chinese one was, but I can remember now there was talk about a Chinese.
There's quite a bit of stuff, and you just don't.
Yeah, it's even worse than I thought. Then we're taking that into account. The Russians are going up with missiles, and the Chinese.
Oh well. Anyway, there's a question from Alan Kennedy, but and a quick thanks from Stuart. A question from Alan Kennedy, but we'll get Pete to answer that one, Alan, when he does his next section on Murray Sky at Night for the next month.
All right, okay.
Okay, you ready for me now, are you?
Yes, that's great, Peter. Way to go.
Right, as I say, Mick was meant to have been doing this month, but he's decided to go away and hold up the traffic on the roads with his caravan. Stuart, do you want to just stop your video there, please?
Oh, sorry.
And your mic as well.
Yeah, my apologies.
As I say, he's decided to hold up all the traffic by taking his caravan out and going on holiday. How dare he? No, we'll let him have a time off now. Again. Right, as I say, this is going to be the first time that I've tried this on Zoom. We've had a little practice run. It does work, sort of, but bear with me. We'll see how well it works and whether we do it again, but I can't see there being too much of a problem. Now, I had a quick run through with this last night. It took me about an hour and a half, so we shouldn't be here too. No, I'm joking. Honestly, I'm joking. Should have this done with about 15 minutes. What I'm going to do is I'm going to go back to a little bit of basics, as we've got a few new members here. I don't know how knowledgeable they are of the night sky. So we'll go back to basics and make a start by showing you just how to find your way around the sky and some of the things you can see in the late summer and early autumn sky, August. I'm going to turn my video off just to help with the bandwidth with this a bit, and then we'll get started. Okay, so when we go out at night as astronomers, we get ourselves orientated, as I say, because the sky always changes, it's always moving around. So we get to know some of the more well-known asterisms, like this one you can probably see here, which is the Plough. And I say that is an asterism, it's not a constellation, it's just part of the constellation of Ursa Major, the Great Bear. This is the whole constellation of Ursa Major here. Okay. Now, if you take this star and that star, this is Dubhe, and that one's called Merak. These are known as the pointers. If you follow them up through, the next fairly bright star you come to is this one here, and that is Polaris, and that is in Ursa Minor, the Little Bear. So we've got the Great Bear and Little Bear. Okay, so that is Polaris, the North Star. So once you find Polaris, you know you're facing north, and you can then get yourself all orientated for anything else that's going to be coming up in the sky over the night. So say Ursa Major and Ursa Minor, the Great Bear and Little Bear. If you don't know what they look like, they look a little bit like this. Okay, Great Bear and Little Bear. There's a reason that they've got long tails. It goes back to Greek mythology times. Most of the constellations you see date back to that sort of time. Basically, these two bears upset one of the ancient gods. He grabbed them by the tail, swung them around, and flung them into the heavens. That's the reason why they have long tails. If you can start seeing some of these pictures in your mind's eye, it just help. It does help you to picture the constellations. Okay. So moving on from there, through Polaris, we come to this W shape in the sky, which is Cassiopeia. Queen Cassiopeia sat upon her throne. Okay. Now, the reason I've chose these three constellations is they are what's called circumpolar constellations. By that, it is meant that they will never set from this point on the Earth. Okay, so from this point in Britain, these three constellations, as well as a couple of others, will always be up above the northern horizon. So they're always there, no matter what time of the year. You can get out there and get yourself orientated and find some of these wonderful, wonderful objects in the sky. Okay, we're going to start off by actually going back to Polaris. There's something here you can have a look at, even in binoculars if you got a good enough sky. Center in here, we're going to zoom in a little bit. Let's say the zoom in is going to take a little bit of a while. It does take some time to come in when we're doing this on Zoom. But Polaris actually makes up the diamond of what's known as the diamond ring. There's a cluster of stars in a circle shape here, and Polaris is actually making up the diamond ring. You can pick that up in binoculars and in a telescope as well. Okay, so something easy to start with, something easy to find, and easy to look at. Okay, so as I say, we now know we're facing north. Okay, so if we then turn around, I'll do this fairly slowly. 90 degrees, we're then facing east. And rising at the moment, this time is set for, as I say, 10 to 11, round about mid-month, yeah, 15th. At that time rising, we have Mars. Okay. Now, Mars is quite difficult to see. You want to wait until it gets higher above the horizon than that to view it. But do have a go if you've got a telescope or even a good sort of pair of binoculars. You won't get to see Phobos and Deimos, I'm afraid to say, not unless you've got a massive, massive telescope. But you can sometimes, depending on seeing, I've seen it once or twice since the times I've been looking out at Mars. You can sometimes get to see the markings on the planet's surface. And depending on the seasons and the way that Mars is faced, you sometimes see the north and southern polar regions as well, you know, the ice caps that are there. So worth having a go, but probably a bit later in the year, once it gets a bit higher in the sky. Okay. So as I say, we turn 90 degrees, we turn another 90 degrees, we're then facing south. Because as you know, you don't have south, east, north and west printed on the horizon for you, unfortunately, do you, when you go out observing. So in the south at the moment, we have the two bright planets of Jupiter and Saturn. Very, very low, almost at their lowest point of their journey around the sun, as observed from here on Earth in the northern hemisphere. Great if you're in the southern hemisphere, but not so good in the north. Okay, so brightest on the right is Jupiter. Absolute stunner to see. Even in binoculars, you can pick up some of the moons. Believe me, have a go. Don't be afraid to have a go. If you've got a small pair of binoculars, get them out, look at Jupiter, and you might be surprised at what you can see, if the seeing is good. And if you've got a telescope, you can zoom in a little bit, and you'll get to see the bands around Jupiter. Okay, you'll get to see the northern equatorial band, southern equatorial band, and these features on there. You might actually get to make out that Jupiter isn't circular either, that it's actually like squashed and is wider around the equator. The reason being is that Jupiter spins so fast, it spins at night. It will spin once every 9.2 hours, I think it is, or 9.9 hours. But spinning so fast, it actually causes the equatorial centers to actually stretch out a little bit. So if you're out for 9 hours, you can get to see the whole of Jupiter as it rotates around on its axis. And you will get to see the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. Say, depending on what other equipment you got, you might get to see a couple of the others, but you'll need some big equipment for that. Okay, where were we going to go next? Right, so now we're facing south. As we look up, say Jupiter and Saturn. Oh, hang on, I forgot to do Saturn. Got to do Saturn. We cannot miss Saturn. The one thing that got me hooked into astronomy when I seen this first through a telescope. Maybe through my bedroom window at a very young age, but it's what I got to see. And to say, if you've got a telescope, you've got to look at Saturn. No matter how low it is, how bad the seeing is. Once you get to see these wonderful, wonderful rings of Saturn, it's something that just mesmerizes you forever, and you always go back to it. Okay. Moon-wise, yeah, you'll get to see Titan, which is normally further out than this. I think Titan's way out here. Okay, you will get to see Titan, no problem at all. The other ones, probably not. They're very, very dim. Okay, give an idea. Titan, the moon of Titan there, that one's magnitude 8.5. Whereas Tethys and Rhea are 10.4 and 9.9, so they're very, very dim. Okay. Okay, so what I say, we're looking south now, and dominating the southern sky are the 3 stars up here. These are known as the summer triangle. Okay, 1, 2, 3. So first off, we have Deneb in Cygnus the Swan. Now this is one of the constellations that I think does actually look like what it should look like. I'll put the artwork on for you again. Okay, you have the swan, wings outstretched, flying down the Milky Way. And we'll have a look at this star in here in a little while. This is Albireo. I'll tell you about that in a moment. Then next over here we have, oh, not there, sorry. Get rid of that one. Over here we have Lyra, Vega in Lyra the Lyre. Okay. And when I say lyre, I don't mean mum, mum, I didn't do it, mum. It's, you know, it's a little musical instrument. It looks something like that. Okay. And then down below, we have Altair and Aquila the Eagle. Okay. So these 3 stars make up what's known as the summer triangle. Now, the one thing to have a look at to start off with, nice and easy to find, is this star at the bottom here that makes up the eye or the beak of the swan. This is Albireo. It's a beautiful, beautiful double star. Now, I was out with my young daughter, Hazel, looking at the comet the other week, and Albireo was, you know, Cygnus was behind us. I turned around. She had a pair of binoculars with her, just 10x40s. And I said, have a look at this star and see what you see. She said, oh, you can see one that's orange and one that's blue. That's pretty good. My eyesight won't spit them now in binoculars, but in a telescope, you can get it lovely. It's a stunning thing to see. So you get the magnification up a little bit, and you'll get to see this star here is a bright orange in color, and this one here is more of a, I say blue, but I see it as greeny, jady sort of color, but other people say blue. But have a look at that. It's a stunner. Okay, so again, nice and easy to find. So I will try and get this done as quick as I can for you. So we're going to have a look into Lyra. So this is Vega. You cannot miss Vega. It's so, so bright. But just off from Vega is this star here, known as the, well, it looks like a star, but it's known as the double double. If you can get the magnification up a bit, you can actually split these 2 stars into a double system. Now, these two stars are actually doubles themselves. Now, you need a lot of magnification, a good night seeing, but sometimes you can split them up again. So that's known as the double in Vega. We're going to have a look at one of the first planetary nebulas, nice and easy to find. Again, it's in Vega, between the two bottom stars here. I'm going to come in a little bit and up a touch. So the two bottom stars here, there's a star you can pick out just about down here. With binoculars, it's just outside naked eye range. Once you zoom into there, then come up a little bit, just here, we have what's known as the planetary nebula. Well, missed it by a smidge. Here we go. Known as the Ring Nebula, planetary nebula. Now, planetary nebula is a little bit of a misdemeanor. Okay, it's got nothing to do with planets. It's got nothing to do with nebulas, really. They were named. I think it was William Herschel that named it because he's seen these nebulas and thought it looks like a planet, but you could see it was gaseous, so it was more nebulous. Had gas around it. Really, it was him that called them planetary nebulas, and the name was stuck. But what they actually are here, what you've got here, is the death throes of a star. Okay, this is where stars reach the end of its life, expanded, contracted, expanded, contracted, a little bit like they believe Betelgeuse is doing at the moment, and then finally it can no longer hold itself together and blows itself apart. So you see the gassy shell running around the outside, expanding out into space. Now, before we head towards the southern horizon, we're going to have a look into Hercules. Now, Hercules is awfully difficult to find. It's fine when you've got all these lines around it, but if I turn the lines off and the names off and move the screen a little bit, it sort of vanishes into the distance. It's very hard to find. Now, there's ways of finding Hercules. I find the easiest one is to go from Deneb here through Vega, and see, I'll take my eyes off and I've almost lost it. And then you see the keystone here in Hercules, maybe this keystone like that. So it's very difficult to see because most of the stars within that keystone, the bright stars, aren't that bright. The brightest one is that one at 2.8. Okay. Now, so between this star and that star is one of the best globular clusters in the sky. It's just about here. Now, globular cluster, so there it is. So with the bottom star, the keystone on the right, and the top star, it's just here. You can pick it up in binoculars ever so easily. A telescope really shows it for what it actually is. So you've got a globular cluster there that's thousands of stars, all gravitationally bound together. Some of the older stars are in the galaxy. And it's an absolutely stunning little thing to see. Once again, fairly easy to find once you find out how to locate Hercules. And if you want to know what Hercules looks like, to get that in your mind's eye, there we go. Okay. Right, another few minutes. What I'm going to miss the we're going to head down the Milky Way here. Okay. So back to Jupiter and Saturn, fairly easy to find. But in this area, let's say you're looking into the center of the Milky Way. Okay, this is the bulge of the Milky Way, or the top half of it, or bottom half of it. There's no upside down in space, so we can't get either. But within here, there's a stunning amount of different nebulas and everything else to see. Now, there's one or two. You've got to be quick to get them because the nights are just getting dark enough to see them. But you can see yourself, they're heading southwest now, so they're going to be setting very soon. So we're going to go in a bit. And the one you really want to try and get, if you can, if I can find it, is, I've lost it. Oh, it's doing so well. Give me a second there, people. See, even the best of us lose where we're going sometimes. I'm going to cheat. Sorry about this. I'm going to have to cheat. If it's going to let me, it's not going to let me. Uh-oh. Shouldn't have done that. It's now frozen the screen. Give me a minute there. Oh, no. I've had a fear this was going to happen. I had a fear this was going to happen. Right, it looks like I'm gonna have to end it there, people. Oh, no, we're back. We're back in life. No, we're not. Right, turn it off. There it is. It's come right in front of me. I knew I found it. I was looking for the number and it gave me the name. That's why I couldn't find it. This is M16, the Eagle Nebula. Okay. Once again, quite difficult to see. It's not that bright. But if you get it into a telescope and you can pick up the center bit, this is the part what's known as the Eagle Nebula, I believe, the Eagle in there. Okay, and this is the nebula that was made famous by one of the first Hubble Space Telescope images. And they say along this region here is what's known as the pillars of creation. You've got all this gas and the dust that's blocking out the light from behind the stars here and causing these silhouettes within the gas. Okay, now this is a proper nebula. As I was saying about planetary nebula, it's not actually nebula. What you got here is a lot of hydrogen gas collapsing down, creating stars, and all these stars around here are very, very young blue hot stars. So you've got to be ever so quick this time of year to catch that. Very quick indeed. Now, I was going to show you more of these down here, but you can have a look at this yourself. So they say this bit of software still, you know, is called Stellarium. You can download it yourself and have a look in there and see what you want to find. So cut it a little bit shorter than what I was going to do. Okay, so we're going to move back up. We'll soon be heading back towards the major where I'll be finishing. But just before we do, there's another one up here I want to show you, which is nice and easy to find with the naked eye. Let's turn that off. Okay, so here's Albirio, that beautiful double star I said about. If you just drop down from there, you can see this cluster of stars in the sky here. This is the Broccoli cluster, or also known as the coat hanger cluster. Okay, so if you look at that coat hanger upside down. Best seen in binoculars, this one, okay? Telescope is no good really, so it just blows the thing apart. But whilst we're in here, we're just going to have a look at this between this constellation here, which is Vulpecula. Somehow that's a fox, I have no idea how. It must be on the Glenfiddich Shandies when they made that constellation up. And then to this bright star here, Sagitta. Okay, drop down to this star here. Have a look around that area. And just up a bit, he says, am I going to cheat again? I think I am. Just to the side here is what's known as the Dumbbell Nebula. This is another stunning planetary nebula, very easy to see. It looks wonderful in the telescope. Get up there, get out there, have a look at that one. It's absolutely stunning. So once again, this is the death throes of a star, when the star has exploded and the gas shell is expanding out into space. Right. I'm just going to head now, because obviously there is something happening this month that you're all going to want to have a look at. If I can get all the constellations up. Okay. We're going to head from Sagitta to the east, looking in towards Pegasus. So this is the square of Pegasus here. And then obviously the most distant thing you can see with naked eye is Andromeda Galaxy, which is just there. So come from the square of Pegasus out this way. Find this star, Merak, which is another beautiful double star actually is Merak. Have a look at that while you're there. Move up 1, 2, 3, and then you can head up into the Andromeda Galaxy. So you can see this with your naked eye. The most distant thing you can see with your naked eye, 2.5 billion light years away. A pair of binoculars is all you really need, but a telescope is a stunner to see it in. Okay, and also you will get to see its two satellites, its two satellite galaxies, which is M101 and M32, which is here, I think. Yeah. Okay. Always worth to have a look at while you're there. And what you got there is a galaxy that's almost edge on to us, but not quite. So you get to see the wonderful dust lanes. So I'm going to head from there into Perseus. That's something you can see nice and easy with naked eye or binoculars. Working from Cassiopeia, the center star, and this star here, down to there. This is the double cluster. So nice, I'm doing a few nice and easy things to find rather than anything too difficult. Okay, so we've got the double cluster just here. One cluster of stars here. This program doesn't really do it justice. It's much better in binoculars. You've got one cluster of stars here, one cluster of stars there, each cluster containing around about 3,000 to 3,500 stars each. As I say, in Perseus at the moment, we have the Perseids happening on the 11th and 12th of of this month, over the night of the 11th and 12th. 12th and 13th is what it runs into. Well, 12th and 13th is the main one, but it can happen either side of that date. Okay, but the 12th and 13th night should be the best. And this is the radiant of the Perseids, so this is where they will be coming from. Okay, the best way to observe this is if you can get that radiant behind you. If you lie down on what I call a star lounger, which is basically a sun lounger that you use at night, looking up, keeping that behind your head, you should be able to see more Perseids than if you just stood there looking up. And if you stood there looking up, you're going to get such a stiff neck, believe me. Okay, so get your star loungers out and have a look at that. And to finish off, we're just going to head back around to Ursa Major and show you one of my favorite sights in the sky. And I always love looking at this. Whenever I go out, I take a look at it. Two galaxies in the same field of view. Now, the way you get to that, okay, is from the pan of Ursa Major, taking this star and that star, moving out about the same distance again, and you'll come across these two here. This is M81 and M82. Okay, and you can fit both of these in the same field of view in an eyepiece. Now, to remember which is which, it's quite simple. M82 looks like a 1 and M81 doesn't. Okay, it's simple, isn't it? Yeah, okay. So you've got this spiral galaxy here that's actually almost face on, not quite, so you get to see the wonderful structure. I'm going to go in a bit better for you. There we go. Just get to see the wonderful structure of the spiral arms. And this one here, M82, is what's called a starburst galaxy. There's lots of active regions running through the center of it. So I'm going to leave it at that. I was going to do more, but we've run out of a little bit of time, but there's always time for Mick to take over next month and have a go with it and show you some more. I'll take any question.
Okay, Pete. Actually, we've just a comment really from Eric about the M13. He says, no doubt about it, it's the best globular cluster in the Northern Hemisphere, and I think he's
well, I don't know, because I was going to show you the Perseids, not Perseus, the Pegasus cluster, and I think that looks pretty good, whether it's because it's the area that's in the sky. And M3 is another good one as well, but M13 is definitely the easiest one to find, I would say, though.
And there's a question here from Alan Kennedy. It's just a technical thing about, you say that the webinar has been recorded. Will it be uploaded onto YouTube as the BAA do? It
will be, yeah. We normally put them up a month later than when they've gone out, just so we got time to process them and make sure we haven't got any copyright issues. But yes, it will be. And all the other ones are up there. All the other ones apart from last month's is up there already. That'll be going up in a couple of days' time.
Okay, Pete. Well, thanks very much for that. That was a great trip around the universe.
I did keep an eye on it. We weren't losing too many people either, so that's good. Yeah, I didn't bore you all. Okay, we'll just finish off with a little bit of club news then. We're doing okay. Yeah, as I said earlier, we are making contingency plans, you know, for meeting back in the hall safely if and when we can. But as I say, I was thinking it's going to be October the earliest. I think it's probably going to be even later than that now. So we will just carry on using the Zoom. As I say, because with this local outbreak in Aberdeen, you know, we've got to be ever so careful with what we do. But we will keep you updated and let you know. And to answer Kennedy's question there, I was going to say about the Sigma on YouTube. As I say, all our videos will go on YouTube. The monthly meeting, the weekly how-to meetings are there as well. You know, the one for Stellarium and Heavens Above. So go and have a look at them. If you didn't see those, go in and have a look, because there's some really, really good information on there from myself, Mick, and from Martin as well. Observing nights. We were hoping to start up the observing nights again if we could do it safely by, you know, safely distancing and the like, but I don't think it's a wise thing to do at the moment. Even if we could. Sorry, Rich, could you turn your mic off, because we can hear you tapping, and turn your screen off as well. As I say, that yeah, as I was saying, the observing nights is not going to be safe for us to do so. As I say, we're hoping to get together for the Perseids, but I don't think we can. I think we need to show a bit of due diligence here and not do this until we are reasonably safe, reasonably happy that they're safe to do so. What we might do though, for the Perseids, perhaps I will, maybe we'll open up on Facebook. We can have a chat on Facebook while we're all outside and just talk, talk together there while we're watching the Perseid meteor shower, which is normally cloudy anyway. But this year, if we can't get together, it'll probably be clear. Okay. Invite a friend. To say it is Sigma's raison d'etre, to make astronomy, available to as many people as possible. I know we have been with this sort of, you've got to join before you can come onto the Zoom meetings. What I'm thinking of doing is, if anyone's got friends who want to come along onto this, who've got an interest in astronomy, just let me know their email and I'll send them out an invite, so they can join in. Obviously, we've got to be a little bit careful because we need enough rooms for our members and our associate members as well. So the weekly how-to sections, as I say, we've dropped off with them a little bit because, as I say, a lot of us are back at work, and as I say, we're struggling a little bit for time and with other things we got going on. But I will try and get something organised so we can do something there. Don't forget, if you got anything from me, just ping me an email. Okay, your astro photographs, if you've got any, pop them into the members photo email as well, and we'll pick them up and get them shared around. And I say with that, I just want to thank Graham for his talk. Our next meeting is on Friday the 4th of September, not the 3rd, as it was said in the newsletter. That's one of the typos we had. If you find the other one, I might let you know what it is. Okay, I might give you a prize or something for for finding the other typo. Give you a clue. It was in the night sky section. So our next meeting is on the Friday the 4th of September, where we've got Finding Planets Around Other Stars with Professor Ken Rice from the Royal Observatory in Edinburgh. Always an interesting one when they go looking for life out there. So we'll carry on. We'll be looking in other solar systems rather than our solar system next month. So with that, I want to thank Graham for his wonderful talk and just explaining how big the solar system has got. Stuart for the Space News. I'll thank myself, yeah, why not? I'll thank myself for the Sky at Night, Morning Sky at Night, the MSN, and for your good selves for joining us, as I say, because it is encouraging that people stay on. We're running on a bit late, but we're all astronomers. It don't matter if we stay up late, does it? And with that, we'll see you next time. Thank you very much for joining us, and good night.